Okay, today I want to show us the relationship between a sector and a cone. Why I have introduced the circle here is because it is important to know the origin of the sector. This sector is from the circle. So if you look at the circle, we know that from the center, which I've called C, to a part of the circumference, that means if you draw a line that touches the surface of the circle, that line will be called the radius. So I can call this radius as well. So a sector, what forms a sector is if you have two radii, that's the plural of radius, and a part of the circumference, because if I take a line, if I take the distance around this circle and measure it, right, it is what we call circumference. So a part of the circumference is what we call the arc. So I'm going to call the distance AB, I'm going to call it S. All right. So if I cut out this my portion of the circle, which is a sector, in real life this looks like a pizza, right? Because this is the same scenario for a pizza where you have the circular pizza and then you cut it into different sectors. So this will be the radius, this is R, and this is S. Now we are done with our circle now. Or maybe one of the many equations I'm going to assume you already know, which I'm not going to derive in this problem, is that I'm assuming that you know the area of a circle. I'm going to call it A sub C. Area of circle is given by pi r squared. So we're going to be using this relation. And I'm going to assume you know what the perimeter of a circle is. Perimeter of a circle is 2 pi r or pi d, but we're going to be using 2 pi r. And then another thing I want to believe you know is the formula to calculate the area of a sector. I'm going to call it A sub S. How small this sector is compared to the circle is just this angle. So we're going to say that this angle subtended by the sector over the total angle in the circle, which is 360 degrees, then multiplied by the area of the circle, which is pi r squared. And then another thing we can also say is that this arc length, that's this S here, all right, which is also a part of the circumference. Now you see the two relationships there. The whole sector, the area of the sector is a part of the area of the circle, while the length of arc is a part of the circumference of the circle. So I'm going to call it, this S is going to be equal to the same analogy, theta over 360 degrees, now times 2 pi r, since it's a part of the circumference. So I'm going to assume you know that already. And the last assumption is that I want to believe you know how to calculate the volume of a cone. I'm going to call V sub C, which is given by pi r squared multiplied by height. Now, let us go down to business. Very quickly, I want you to see some things. Notice that from this sector, if we happen to fold up this sector this way, all right, what's going to happen? It's going to form this cone. So a sector, or rather a cone, is gotten by folding a sector. Now, see, many things are going to be happen there. Notice that this radius is still going to be this length here, which we normally call the slant height of a cone, represented by L. So what's my first relationship there is that R is going to be equal to L. You understand this, then you are almost getting there. And then another thing is that this arc length, which is S, is going to become the circumference of the circular base. Notice this circular base is just gotten by folding the cone, the sector, which is that S. So another relationship there is that what S is going to be equal to circumference of cone. So I'm just writing like the circumference of cone. Understand these two things, and then that is all you need actually, because even if I derive the formula, if you forget the formula but if you still remember this relationship, then you are good to go. So let's derive the formula quickly. Okay, let me start from this. What's S? We already know that S is given by theta over 360 degrees times 2 pi. Now I'm going to use capital R, all right, because this R is the radius of the circle from whence we got the sector. So to differentiate the radius of the initial circle and the radius of the small circle, which is gotten from the base of the circular cone, or rather the circular base of the cone. So I'm going to use capital R for my radius. So theta over 360 times 2 pi r, we have said that is equal to the circumference of the circular base of the cone, which is 2 pi small r. Now, since 2 pi and 2 pi are the same because pi is constant, we can cancel the 2 pi. So we're now going to have that theta times r over 360 degrees is equal to small r. We need to make theta the structure of the formula because that is the angle subtended by the sector, which some questions will ask you to find that angle. So let me just do it quickly. Let me cross multiply. I'm going to have theta times r is equal to r times 360 degrees. Then we divide both sides by r finally now. Divide both sides by r. What are we going to have? We're going to have that theta is equal to r over capital R times 360 degrees. And this is the formula that connects the angle of the sector, the radius of the circular base of the cone, the radius of the circle, and 360 degrees. So this is the formula you need. Remember, even if you forget this formula and remember this relationship, you're still good to go. All right?